So this is a maths GCSE question that I was asked from a relatively bright, smart young cookie. And the question goes like this, and I've actually made an assets folder over here. So you can see like there's an assets folder, and I've copied the picture of the question. So the question looks like this, at least in terms of the image of it, and the actual text of the question is: describe fully the single transformation that moves the shape S to the shape T. And the first thing to note is we need to just be aware of the which direction we're actually going in. So we're going from S to T, and I've taken the liberty of drawing kind of lines over it with arrows pointing in a direction. Now we're starting at S and we're ending at T. And one of the things that I point out is it doesn't matter which coordinate, which point you take, so long as you take the exactly same corresponding point on the other shape. So we're going from S to T here. We could do red dot to red dot, and we could also do yellow dot to yellow dot. But I just thought this would fit in quite nicely with lists, in terms of we could actually do this in Python. So the first thing that we could do is we could take these red dots, and we need to get the coordinate positions of the red dots. So red dots, and we can have something like start point equals, and it will be some pair of values, and then an end point, and then equals, and again some pair of values. And finally we want to calculate the transformation. So transformation equals, and then again there ultimately will be some pair of values, but at the moment we don't know what this is. This is what we want to work out, so this is an empty list to start with. Let's go to the start point and just see where that is. So if we just click back here, we've got the start point, which is at the x coordinate of 1 and the y coordinate of -3. So it's 1, -3, 1, -3. That's our x position over here, which is 1, and our y position over here, which is -3. So we could say that it's looks like x, y. That's the format that we want to get. And we now go and find our endpoint in the same way. And the endpoint is this red dot, this corresponding red dot up here on the T shape. And that is at position x equals -4 and y equals +3. So we've got a -4 over here for our x position and a +3 over here. We don't need to put the plus in, so just +3 over here. And that should be it. And we've got our transformation. Now, we can do something quite cute in Python, and there's a few different ways of approaching this. We didn't have to create an empty list, but this is one nice way of doing it. We can do a for loop, and we can, this is, again, just remember, this is called an iterable. We can iterate over the items of the list. So we can do something like for I, v, we'll discuss what they are. I'll put a little space there actually, because it just gets nicer, in, and then we're going to use this new function in Python, which is enumerate, which actually we have seen before, but we've never specified it as enumerate, and then start point. So something like this, we want to jump over all of the items in start point. Now there's only two items, this item here and this item here in start point. And I'll just put a placeholder for the meantime pass. We won't do anything at this point, but let's just have a look at this, right? What does enumerate actually mean? And if I actually hover over it as well, enumerate here takes in an iterable, which is a list and potentially a start, and returns an enumerate object. The enumerate object yields pairs containing, so we get the enumerate object contains pairs containing a count from the start, which defaults to 0 because we usually start at index 0 in a list, and a value yielded by the iterable argument. Now, what does that mean? Let's just have a look. Over here, if I just take the start point, for example, we could take any one of these. I just take the start point and open it. The enumerate, when we look at a list, we're really just looking at the values. So when we iterate through a list, we're just looking at values. And here the values are 1 and -3. They were the x and y coordinates. But if we do enumerate, it not only gets the values, but gets the index as well. So the index comes out. So this is index 0 with value 1, and this is index 1 with value -3. And the enumerate method is able to extract that. So that's what enumerate does. And we can utilize that quite nicely, because then we can do transformation dot append, and then we can do, and again, what we're actually doing, we've got this empty list and we're adding items into the list. The first item that we're going to add is going to be the index 0, which represents the x coordinate, and then we're going to jump over to the next one, which is index 1, which represents the y coordinate, which is the second value in the list. So all we have to do is end, over here inside the brackets, end point of I and minus start point of I. The first item in the list, or the first index in the list, will be index number 0, and the next index in the list will be index number 1. Now, we could actually use this v value as well, and we could place it in here, but it looks visually cleaner to use I and I in terms of what we do, but sometimes I would just put v into here for the start point, because we've extracted the index and the value from the start point, and the value is -3, and start point of index 1 is also -3, for example. So we're able to do that. And then we can print our transformation. So we just start with something like this, transformation. And when we run our piece of code, I'll just move down the Jupyter variables. When we run our piece of code, we get these transformation, which is -5, 6. And we might just want to make this look a bit nice. But actually, let's just go onto our picture and just see if this is correct. So here's our question. And the transformation, let's have a look. We've got in the x coordinate, in the x-axis, so on the horizontal axis, we are going back 1, 2, 3, 4, 5. So that's our -5, because we're going backwards to the left-hand side. Positive is to the right-hand side, negative is to the left-hand side. And we are going upwards, which is a positive value on the y-axis. If we were going down, it'd be a negative value. So it is 1, 2, 3, 4, 5, 6. And indeed, that's what we got over here, which is -5, 6. Now, the thing about this is that we did it with red dots, but we could also actually do it with the yellow dots. So let's just, and at this point in time, I guess we shall do print, open brackets, close brackets. And we just call this the red dots transformation. The red dots transformation. The red dots transformation. So the red dots transformation looks like this. And then we're going to work out the yellow dots transformation. Now, one thing that we can do, we probably wouldn't do it like this, but for the purpose of the question, it's quite simple to copy and paste everything here and just stick in yellow dots. And we still got our x and y coordinate for the yellow dots. And this time what we need to amend is the start point and the end point. So we just go to, I will close this one out, just go over here and let's look at our start point for the yellow dot. It's that x equals 4 and y equals -3. So that's 4, -3. So this is 4 and this is still -3. Nothing's changed there. And then let's look at the end point. Where are we moving to? The same position on the S shape. We need to get that same position on the T shape, and it's at x equals -1 and y equals +3. So we are at -1 and +3, and we've still got this transformation, which is an empty list. We are hoping to populate this vector, and we can do exactly the same process, which is this enumerate. We're going to hop through the items in the list and do the subtraction. So we're going to do the 4 minus 1, and then we're going to do the -3 minus +3. That's effectively what we're going to do in this list. Or sorry, the other way around. We're going to do end point minus start point. So it'd be +3 minus -3, and we've got -1 minus +4. That's what we're going to have, and the result will be, instead of red dots, it'll be yellow dots. Now we see over here, pictorially anyway, that this pink arrow is the same length and same direction exactly as this other pink arrow. So both the pink arrows are parallel there, and they are of the same length as well. They are exactly the same vector, but we will see this in the code hopefully if everything works properly. So we've got our red dots here, and we're going to run our code. This time, for the sake of it, I won't press Control Return. I will hit Run over here, just so you can see me executing the cell. And indeed, we get the red dots is -5,6, and also the yellow dots transformation is -5,6. It didn't matter where the transformation was from, so long as we were consistent with picking the point on the object. And this is one of a number of methods that we could have used in Python. This is a relatively simple and straightforward method. So this is a standard maths GCSE question, and it uses lists in order to get the solution.